Hi, my name is Liam McGregor. I am from Ryan Park Elementary School. My title is Winter is Coming. Should your batteries be afraid? Batteries are used all around us in our everyday lives. They are in toys, cars, phones, and computers. Batteries are also used in EVs, electric vehicles, and for renewable energy. I wanted to see how the performance of batteries is affected by the temperature of its environment, and will batteries perform better in different climates? My hypothesis is I think batteries will last longer in a warmer environment than a cold one. I also tested different types of batteries and different technologies like lithium-ion and nickel metal hydride. I wanted to see which one of these batteries would perform better in a colder environment. And the difference between lithium-ion, nickel metal hydride, and alkaline is that lithium-ion and nickel metal hydride are rechargeable. And lithium-ion is just a newer technology of nickel metal hydride. On this slide, you see the materials I used in my apparatus, and also the materials I used for testing. Now, while you look at the materials, let me tell you a little bit about how a battery actually works. A battery has all these different chemicals inside of it that when they mix, they release electrons. Those electrons store at the negative side of the battery, the flat side. When you connect something from the negative to the positive side of the battery, those electrons want to move away from each other, so they go to the positive side. If you put, say, a light bulb in the wire's path, the electrons will go through the light bulb to get to the positive side, which causes the light bulb to light up. The procedure for my project begins with the building of my apparatuses. I really liked this because I got to learn how to solder. I used this to connect the wires from the battery holders to the lights and fans. I also used a hand drill to drill the holes. Once the apparatuses were complete, I could begin setting up for my trials. Before I could start the trials, I placed the apparatus and the batteries in the testing climate for 30 minutes to adapt them to the temperature, the variable of my experiment. I also placed a thermometer in each testing environment to control the variable and have a consistent temperature. The control for this experiment is the room temperature climate of 68 degrees. The refrigerator held constant at 40 degrees, and the freezer held at 0 degrees Fahrenheit. When the 30 minutes were up, I could then place the batteries in the apparatus. Next, I made sure the light was on and the fans were spinning, and noted the start time. When the light went out or the fan stopped spinning, I recorded the stop time. Each type of battery was tested 3 times each, in all 3 environments for a total of 27 trials. I recorded all the times in my data log. Then I had to convert the times into minutes before I entered the data into a spreadsheet. Initially, I used alkaline batteries because these are batteries most people are familiar with. I decided to add additional trials with lithium-ion and nickel metal hydride batteries because I wanted to see which type of battery performed better in colder temperatures. For my results, I found that lithium-ion batteries performed better in the colder temperatures than the other types of batteries. One thing that I found interesting was that lithium-ion batteries performed better than the control test during the light trials. My hypothesis was proven correct. The results of my experiments show that the performance of batteries worsens as the temperature decreases. For example, during the fan trials, the lithium-ion batteries showed a decrease in capacity of 12% and 23% for the 40 degrees Fahrenheit and the 0 degrees Fahrenheit tests. These were the lowest reductions in the performance I saw. As I was doing these tests, I found that the trials took longer than I expected. I had to start the trials in the morning, so that I would be awake when they ended. I decided to use percentages of capacity instead of time for my results because the different types of batteries had different capacities. Using percentages made the results more accurate. In the future, I might add another test to see how batteries perform in hot climates. Temperature's effect on a battery's life is important because we depend on batteries to operate many items for everyday use. We use batteries in our cars, phones, lights, toys, and computers. Portable medical devices use batteries. They're everywhere. What happens if they die when we most need them? Green energy is great, but what if there's no sun for solar panels, or there's no wind for wind turbines? We need to find a better way to store energy in batteries in all climates. I would like to research this and maybe find a better way to insulate batteries, so they can perform as well in colder climates as in warmer ones. Thank you for your time.